Hi, we're going to do some example problems for elastic collisions. Remember that an elastic collision is a collision where the objects don't stick together after the collision. They bounce off of one another. For example, bumper cars, or when you play pool, or a sumo wrestler collides with another sumo wrestler and they bounce off of one another. Those are elastic collisions. But just like inelastic collisions, that law of total momentum that we've been talking about still applies. So the total momentum before the collision is still the total momentum after the collision. The law is still the law, no matter what kind of collision you have, whether it's elastic or inelastic. The total of momentum of the system doesn't change. So let's try problem 1. This is video problem 1 on your handout. A red ball has a mass of 3 kilograms and is moving to the right at 4 meters per second. It collides with an identical 3 kilogram ball at rest. After the collision, the red ball has stopped. What is the velocity of the green ball after the collision? So it's a good idea to first identify our objects so that we can keep them all in order. So object 1 is a red ball. Object 2 is a green ball. So we've got object red, there we go, now I got my pen. And object 2 is green. Object 1 after the collision is still red, and object 2 after the collision is still green. So now we can go through and start to fill in our before the collision information. So that red ball has a mass of 3 kilograms, and it's moving at a velocity of 4 meters per second to the right. So we have 4 meters per second, and it's positive because it says to the right. So like we've been doing in class, let's circle our information for before. It collides with an identical green ball. Because it's identical, the word identical means the same mass. So we've got 3 kilograms for the green ball, and it says at rest. So that means 0 meters per second. After the collision, this is very important. After the collision, the two objects are unchanged. So the mass of the red ball is still 3 kilograms, and the mass of the green ball is also still 3 kilograms. There's no adding masses here. Now this is where you have to think about it. If I give you a high five, do I lose weight? If I high five you enough, do I disappear? No, that collision doesn't transfer mass. When we had inelastic collisions, the masses stuck together and you added them. But in this case, the masses are just bouncing off of one another. So when you're in bumper cars, just because you bump into another car doesn't mean that some of that bumper car goes to the other bumper car. The individual objects, the masses stay the same. It says in the question then, after the collision, the red ball has stopped. So identify the red ball as having 0 meters per second of velocity. What is the velocity of the green ball after the collision? So we are looking for this box right here, after the collision. So our before the collision is exactly the same steps that we did with inelastic collisions. So we've got a couple of steps that we can do. We're going to multiply mass and velocity. So the mass times the velocity is a momentum. 3 times 4 is equal to 12 kilogram meters per second. The second momentum is 3 times 0. Again, mass times velocity equals momentum. And in this case, it's 0 meters per second, because 3 times 0 is 0, and a stationary object has no momentum. So our total then, after they collide, we add those together. 12 plus 0 gives me 12 kilogram meters per second of momentum before the collision. The law says that the total before and after has to be the same. So I'm just going to carry that momentum over. So the after is 12 kilogram meters per second as well. Now this is where it starts to get a little different. After the collision, we have 2 separate objects. They're not stuck together. So each object has its own momentum after the collision. So red, we can identify red's momentum after the collision by multiplying the 3 times the 0. So we have 3 times 0, which gives me 0 kilogram meters per second. Now we know that the green ball's momentum plus the red ball's momentum has to give me the total of 12. So if I have 0 plus what gives me 12, then the answer is obviously 12 kilogram meters per second. Because 0 plus what equals 12. And I have 0 plus 12 equals that total momentum of 12. So we're basically working our way up. We have 0 plus what gives me 12? Well, that's got to be 12. Now we're ready for our last step. And that last step is to undo my momentum to find a velocity. Remember that we're dividing up. So we have 3 times what equals 12, or 12 divided by 3 gives me 4 meters per second of velocity. So now we can double check ourselves. We know the before, 3 times 4 is 12, and 3 times 0 is 0. We add those together to get 12. We carry the 12 over. And then we have, after the collision, 3 times 0 is 0, because it says that the red ball stops. So the red ball has no momentum. So if we check our work to make sure that we were right, we have 3 times 4 is 12, and then 0 plus 12 gives me 12. And the totals are the same, which is what we need to have. So you can always go back at the end and check your after and see if you end up with the same answer at the bottom. As long as the bottom lines are the same, the total momentum has to stay the same for both collisions. I just noticed an error in the units right here for the object 2 before the collision. This shouldn't be meters per second, that should be kilogram meters per second. Sorry about that. Let's go on to video 2. So let me scroll down here. Let's go down to video 2. So video problem 2, we have a red ball has a mass of 3 kilograms and is moving to the right at 4 meters per second. It collides with a 2 kilogram green ball at rest. After the collision, the red ball is moving at 0.8 meters per second to the right. What is the velocity of the green ball after the collision? So again, identify your objects with the red ball, and we have the green ball. Let's use some color this time on this. And then after the collision, still green for object 2, and object 1 is still red. So let's fill in our information, what we know. So the red ball has a mass of 3 kilograms, moving to the right at 4 meters per second. It collides with a 2 kilogram ball, 2 kilogram ball at rest. So we've got the red ball has a mass of 3 kilograms, and it's moving at 4 meters per second. Collides with a 2 kilogram green ball at rest, 0 meters per second. After the collision, the red ball is moving at 8 meters per second to the right. So the red one had a mass of 3 kilograms. So red was 3. So the red is still 3 kilograms. Moving to the right, so that's positive, at 0.8 meters per second. The green ball, after the collision, is still going to have a mass of 2 kilograms. We're looking for that velocity after the collide. So we're looking for that box. So let's start working through our steps. We know the steps. We love the steps. First thing we do is multiply the momentums together. So we have 3 times 4. It's 12 kilogram meters per second. Let's use my colors again. 12 kilogram meters per second. And 2 times 0, that's 0 kilogram meters per second. The total then, we add them together. 12 plus 0 gives me 12 kilogram meters per second. So the before is the exact same as before. The steps are exactly the same. Okay. After the collision, we have the same total momentum. So we're going to carry that on over. That was a horrible arrow. carry that over 12 kilogram meters per second. We know the totals have to stay the same. So now we have a momentum up here where we have 3 times 0.8, which equals 2.4 kilogram meters per second. So the 3 times the 0.8 gives me 2.4 kilogram meters per second. Now this is where everybody seems to mess up all the time. If I have 2.4 plus what gives me 12, then I'm going to subtract. So I'm going to do 12 minus 2.4. 12 minus 2.4 gives me 9.6. Oops, let me switch colors. 9.6 kilogram meters per second. So double check, when I add 2.4 and 9.6, I get 12. So those individual momentums add together to give me my total momentum. Now I have one last step. I have to take my momentum and I divide it by my mass. So I have 9.6 divided by 2, and I get 4.8 meters per second. Squeeze it in there. So when I double check all my work at the end, so we got a final speed. Let's double check ourselves. From the beginning, 3 times 4 is 12. 2 times 0 is 0. Add those together and you get 12. After the collision, 3 times 0.8 is 2.4. 2 times 4.8 gives me 9.6. And when I add 2.4 and 9.6, I get 12. And 12 before equals 12 after. So I've done it correctly. You should always be able to go back and double check your before and after and get the same total before and after. And if you can do that, then you've done your work correctly. If when you double check the bottom lines are not equal, you've done something incorrectly. Okay, at this point, if you have any questions, ask the teacher, and if not, then move on to the practice problems, the check your understanding question on the other side of your sheet. Thanks. Bye.